Assalamualaikum and hello everyone. So for today's video, we are going to look at how we resolve forces to get the resultant force. Okay, first we have F1 here in this case. So F1, when we resolve F1, we're going to have F1y and F1x. And when we resolve F2, we are going to have F2y and also F2x overlapping F1x. So later on, we are going to do the calculation based on these directions. Okay, so we have done the drawing on the vector component just now. So we proceed with the direction or the calculation of the x and y component. So if you look at this example, we have f1x and f2x and also f1y and f2y. So overall we have 4 components to be filled in here in this table. Okay, so let's start with vector one by one. We start with f1. So f1. So f1 we have f1x, and also f1y. So now we are deducing the equation. So f1x is equal to, so because of the direction of f1x is to the left, so we need to put negative sign. Okay, and the equation is f1, or we can straight away take the number 10 cos 45 degree. And when we look at the f1y, so it is upward, so it is positive. So the equation is 10 sine 45. Hopefully you still remember how to get the sine and cos function here. And the next thing is to look at the component vector of f2. So we have f2x. Again, f2x is directed to the left, so it is negative, and the vector is 40, and the angle is 30. And what about f2y? So f2y here is directed downward. So when it is downward, we have to put negative sign. So it is being 40 sine 30 degree. Okay, and you do the calculation. So at this part is the vector sum. Okay, the vector sum. The sum of the vector. So what we do here is actually summation of all x component is equal to f1x plus f2x. So you have done the calculation here, right? So you have to add up the two numbers. Okay, and the same goes to the y component. So we are going to find the total component of y. So what we do here is we add up the two vectors f1y plus f2y. So you have got the value here. So you're supposed to get negative sign here. So remember, you have to include the negative sign into the calculation. Okay, it's going to be plus negative something, and then you can find the value. Alright, so this is basically the calculation that we have done just now. So we have got the final collective number of summation for x-axis and also summation for y-axis. So now we're in the step of calculating the resultant force or the resultant vector. So you have to know that we have a formula for the resultant. Okay, so the formula is square root summation of force in x component squared plus summation of force in y component squared. And now you substitute the value. So you'll have negative 41.71 squared plus negative 12.93 squared, and you'll get 43.6 49.67 Newton. So this is the magnitude. And now we want to find the direction of the resultant vector. Okay, so this direction will be denoted by theta. Alright, so to make things easier to understand, we refer this resultant force for x and y, and we draw the axis, x and y axis. And now we place this resultant vector, so we can see here that this is for x-axis is negative, so it's going to be at the negative side, and y-axis is also negative, and again it is going to be at this negative side. Okay, so meaning that the resultant force position at this position, at this quarter of this axis. So now we want to find the direction, so it is denoted by angle, and the formula is tangent theta is equal to summation of Fy over summation of Fx. So this is our position of summation of Fx, and this is position of summation of Fy. So substituting the value, we have negative 12.93, negative 41.71, and you do the calculation and you will have your angle is 17.2 degree. And if you refer this drawing, you have to state that the angle is below negative x-axis, because this is important to state the direction. Okay, we have to make sure that all vectors are at the correct position. So there is a vector that is F2 that we need to change its position, because we have to make sure that the tail of all vectors must be at the origin. So now we need to move F2 to this position, this kind of position of these three vectors. So now F2 is at this quarter. Okay, now we are resolving vector F2, so we need to draw the direction. So in this case, F1 is lying exactly at y-axis, so we have F1y is equal to F1. So F1 we don't need to resolve, and F2 and F3, because it is lying between x and y component, so we need to resolve F2 and F3. So as usual, we resolve F2, so we'll have F2y, F2x, and for F3, we're going to get F3x and also F3y. So now we have, overall, we have 5 components of forces: F1y, F2y, F3y, F2x, F3x. And this is the resultant calculation of all the forces. So I've been doing the calculation. This is the results. And finally, you have summation of Fx is negative 49.6 Newton, and summation of Fy is 16 Newton. And as I told you before, to get the resultant, we need to use the equation. So it's going to be square root summation of Fx squared plus summation of Fy squared. So this is equal to negative 49.6 squared plus 16 squared. And then you can have the final answer. So this is the magnitude. To get the direction of the resultant vector, So we are going to apply is equal to summation of fy, summation of fx. So you substitute the values, 16 over negative 49.6, then you have a value in degree. So this is the resultant. Okay, before I stop, I would like to remind you an important point here. So normally we have the angle is attached to the x-axis, right? Okay, so for this case, for vector f2, this angle is attached to y-axis. Okay, so it's either you want to solve this resolving vector, it's either you can find this angle 60 degree and use the function cos and sine as usual, or you can use this angle that is attached to y-axis, but then it's going to be a bit different, so you are going to have f2y with cos function instead of sine, and f2x with sine function. So this is in opposite with what we have learned previously. Okay, so thank you. That's all for today's video.